Emergency lights in commercial buildings must be on a separate circuit from general lighting. This is a crucial safety requirement that ensures the emergency lights will continue to function even if the general lighting circuit fails due to a fault, outage, or any other reason. The purpose of emergency lighting is to provide illumination during situations where the normal lighting system is unavailable, such as power outages caused by storms, equipment failures, or other emergencies. Having a dedicated circuit for emergency lights means that these lights are not dependent on the same power source or circuit protection devices as the general lighting. This independence is vital for ensuring that emergency lights remain operational when they are needed most. The National Electrical Code, or NEC, provides detailed guidelines and regulations for electrical installations, including emergency lighting systems. While the specific requirements may vary depending on the local jurisdiction and the type of occupancy, the general principle of having a separate circuit for emergency lights is consistently emphasized. This separation is intended to enhance the reliability and effectiveness of the emergency lighting system, thereby improving the safety of building occupants. Consider a scenario where the general lighting circuit experiences a short circuit, causing the circuit breaker to trip and energize the entire circuit. If the emergency lights were connected to the same circuit, they would also lose power, rendering them useless during the emergency. By having a separate circuit, the emergency lights are protected from such failures, ensuring that they remain illuminated and guide occupants to safety. The dedicated circuit for emergency lights should be designed and installed in accordance with the NEC and any applicable local codes. This includes using appropriately sized conductors, overcurrent protection devices, and wiring methods. The circuit should also be clearly identified and labeled as an emergency lighting circuit to facilitate maintenance and troubleshooting. In addition to the separate circuit requirement, the feed-to-wall packs, which are often used as emergency lighting fixtures, must be directly connected to the power source. Plug-and-cord connections are not permitted for emergency lighting fixtures. This requirement is in place to ensure a reliable and permanent power supply to the emergency lights. Plug-and-cord connections are generally less reliable than direct wired connections due to the potential for loose connections, accidental disconnections, or damage to the cord or plug. In an emergency situation, any of these issues could cause the emergency lights to fail, compromising the safety of building occupants. Direct connection, on the other hand, provides a secure and permanent connection between the emergency lighting fixture and the power source. This eliminates the risk of accidental disconnections and ensures that the emergency lights will remain powered during an emergency. The direct connection should be made using appropriate wiring methods and connectors in accordance with the NEC and local codes. The NEC specifies the requirements for wiring methods and connectors used in electrical installations. These requirements are intended to ensure the safety and reliability of the electrical system. When making direct connections to emergency lighting fixtures, it is important to use wiring methods and connectors that are suitable for the application and comply with the NEC. For example, conductors should be sized appropriately for the load and protected from physical damage. Connectors should be properly tightened and insulated to prevent shorts or ground faults. The wiring should also be routed in a manner that minimizes the risk of damage or accidental disconnection. In summary, emergency lights in commercial buildings must be on a separate circuit from general lighting, and the feed-to-wall packs must be directly connected to the power source. These requirements are essential for ensuring the reliability and effectiveness of the emergency lighting system, thereby improving the safety of building occupants. Failure to comply with these requirements could result in serious consequences, including injuries or fatalities. The requirement for a separate circuit stems from the fundamental need for redundancy in emergency systems. Consider the implications of a single point of failure. If emergency lights are tied to the general lighting circuit, a fault in that circuit, such as a short circuit or an overload, would disable both the general lighting and the emergency lighting. This defeats the entire purpose of having emergency lights, which is to provide illumination when the normal power supply is disrupted. The NEC addresses this concern by mandating a separate, independent circuit for emergency lighting. This circuit must be supplied from a reliable power source, such as a generator or an uninterruptible power supply, or UPS. This ensures that the emergency lights will continue to operate even if the normal power supply is lost. The specific requirements for emergency lighting circuits are detailed in Article 700 of the NEC, which covers emergency systems. This article specifies the types of occupancies that require emergency lighting, the performance requirements for emergency lighting systems, and the installation requirements for emergency lighting circuits. Article 700.12 outlines the acceptable sources of power for emergency systems, which include storage batteries, generators, and UPS systems. The selection of the appropriate power source depends on the specific application and the required duration of emergency power. For example, a hospital may require a generator that can provide emergency power for several hours, while a small office building may be able to rely on a UPS system that can provide emergency power for a shorter period of time. Article 700.16 specifies the lighting loads to be connected to the emergency system, which include exit lights, exit signs, and other lighting that is necessary for the safe evacuation of the building. The emergency lighting system must be designed to provide adequate illumination to allow occupants to safely exit the building in an emergency. Article 700.26 requires that emergency lighting circuits be independent of all other wiring and equipment. This means that the emergency lighting circuit cannot share a conduit or junction box with any other circuit, and it must be protected from physical damage. The purpose of this requirement is to prevent a fault in another circuit from affecting the operation of the emergency lighting system. The requirement for direct connection of wall packs, as opposed to plug-and-cord connections, is also driven by reliability concerns. Plug-and-cord connections are inherently less reliable than direct wired connections due to the potential for loose connections, corrosion, and accidental disconnections. In an emergency situation, even a momentary interruption of power to the emergency lights could have serious consequences. Direct wired connections, on the other hand, provide a secure and permanent connection between the emergency lighting fixture and the power source. This eliminates the risk of accidental disconnections and ensures that the emergency lights will remain powered during an emergency. The NEC specifies the types of wiring methods that are permitted for direct connections. These wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and armored cable. The choice of wiring method depends on the specific application and the environmental conditions. For example, rigid metal conduit is typically used in areas where the wiring is exposed to physical damage or corrosive environments. Electrical metallic tubing is typically used in areas where the wiring is protected from physical damage. Armored cable is typically used in areas where flexibility is required. In addition to the wiring method, the NEC also specifies the types of connectors that are permitted for direct connections. These connectors must be listed and labeled for the intended application, and they must be installed in accordance with the manufacturer's instructions. The NEC also includes requirements for the grounding of emergency lighting systems. Grounding is essential for protecting against electrical shock and preventing equipment damage. The grounding system must be designed and installed in accordance with Article 250 of the NEC. Article 250.4 outlines the general requirements for grounding, which include grounding of electrical equipment and grounding of electrical systems. The grounding system must be designed to provide a low impedance path for fault current to return to the source. This ensures that overcurrent protection devices will operate quickly to clear fault and prevent electrical shock. Article 250.118 specifies the types of grounding electrodes that are permitted, which include metal underground water pipes, metal frames of buildings, and concrete encased electrodes. The choice of grounding electrode depends on the specific site conditions and the availability of suitable electrodes. In addition to the NEC requirements, local codes and regulations may also apply to emergency lighting systems. It is important to consult with the local authorities to ensure that the emergency lighting system complies with all applicable requirements. The design and installation of emergency lighting systems should be performed by qualified and experienced electricians who are familiar with the NEC and local codes. These electricians should be able to properly size conductors, select overcurrent protection devices, and install wiring methods and connectors in accordance with the applicable requirements. Regular maintenance and testing of emergency lighting systems are also essential for ensuring their continued reliability and effectiveness. Emergency lighting systems should be tested periodically to verify that they are functioning properly and that the batteries are fully charged. Testing should be performed in accordance with the manufacturer's instructions and any applicable local codes. The importance of adhering to these regulations cannot be overstated. Non-compliance can lead to significant safety hazards, potentially endangering the lives of building occupants during emergencies. Moreover, failure to comply with these regulations can result in legal liabilities and financial penalties. Therefore, it is imperative that building owners, facility managers, and electrical contractors have a thorough understanding of the NEC and local codes pertaining to emergency lighting systems. They should also ensure that all emergency lighting systems are properly designed, installed, maintained, and tested in accordance with these regulations. The NEC is a comprehensive document that covers a wide range of electrical topics. It is updated every 3 years to reflect changes in technology and industry best practices. It is essential to stay current with the latest edition of the NEC to ensure that electrical installations comply with the most up-to-date requirements. In addition to the NEC, there are other standards and guidelines that may be relevant to emergency lighting systems. These include standards published by the Illuminating Engineering Society, or WISE, and the National Fire Protection Association, or NFPA. The IES is a professional organization that develops standards and guidelines for lighting design and application. The IES Lighting Handbook provides comprehensive information on lighting principles, design considerations, and recommended lighting levels for various applications. The NFPA is a non-profit organization that develops codes and standards for fire prevention and life safety. NFPA 101, the Life Safety Code, provides requirements for emergency lighting systems in various types of occupancies. By following the NEC, WISE, and NFPA guidelines, building owners and electrical contractors can ensure that emergency lighting systems are designed and installed to provide the highest level of safety and reliability. These organizations also offer training and certification programs for electricians and other professionals involved in the design, installation, and maintenance of electrical systems. These programs can help to ensure that these professionals have the knowledge and skills necessary to perform their job safely and effectively. Furthermore, continuous education and training are crucial for staying abreast of the latest technological advancements and best practices in the electrical industry. It's also important to consider the specific needs of the building and its occupants when designing an emergency lighting system. For example, a building with a high population density may require a more robust emergency lighting system than a building with a low population density. Similarly, a building with occupants who have mobility impairments may require special lighting considerations to ensure their safe evacuation. The placement of emergency lights should also be carefully considered. Emergency lights should be located along exit routes, at intersections, and in other areas where occupants may need assistance navigating the building in an emergency. The lighting level should be sufficient to allow occupants to see clearly and avoid hazards. In addition to providing illumination, emergency lighting systems can also be used to provide other safety features such as audible alarms and visual signals. Audible alarms can be used to alert occupants to an emergency and provide instructions for evacuation. Visual signals, such as flashing lights, can be used to guide occupants to exits and other safe areas. The use of smart lighting technologies is also becoming increasingly common in emergency lighting systems. Smart lighting systems can automatically adjust lighting levels based on occupancy and ambient light levels. They can also be integrated with other building systems, such as fire alarm systems, to provide a coordinated response to emergencies. Smart lighting systems can also be used to monitor the performance of emergency lighting systems and provide alerts when maintenance is required. This can help to ensure that emergency lighting systems are always functioning properly and ready to respond to emergencies. The cost of emergency lighting systems can vary depending on the size and complexity of the system. However, the cost of an emergency lighting system is a small price to pay for the safety and security of building occupants. Emergency lighting systems are an essential part of any commercial building. They provide illumination during power outages and other emergencies, helping to ensure the safe evacuation of building occupants. By following the NEC, WISE, and NFPA guidelines, building owners and electrical contractors can ensure that emergency lighting systems are designed and installed to provide the highest level of safety and reliability. Continuous education and training are crucial for staying abreast of the latest technological advancements and best practices in the electrical industry. Remember to consult with qualified and experienced electricians when designing, installing, or maintaining emergency lighting systems. Their expertise will help ensure that the system meets all applicable codes and regulations and provides the necessary level of safety for building occupants. And always prioritize safety when working with electrical systems. To energize circuits before working on them and use appropriate personal protective equipment.